Hello again from Digicool Things. In part 2, I presented my CreatiVision Controller, which had already gone through 3 revisions to bring it to 1.2 version, where I was finally happy to share my journey with others. Since then, I've made 2 further relatively significant changes. These changes have amended the design significantly enough that I've made a major version increment to version 2.0. So, today I'll present these changes with the updated version 2 schematic and PCB design. I'm pretty excited about these changes, which I believe brings my CreatiVision controller interface to the next level and finalises this particular component of my CreatiVision recreation project. I'm really proud of the finished result. The first change is relevant to using the controller with an original CreatiVision console. The change itself is reasonably trivial, but also relatively significant. As you'll probably remember from part 2, I discovered that using the controller with an original CreatiVision console was necessary for reliable operation to connect a ground reference, so that the 2 devices had a common ground. As with my other 5V projects, I utilised a USB module for actually powering the controller from a separate power supply. Now, on reflection, it seemed to me to be a bit silly to use a separate power supply when we also need to connect to the console's ground reference. Furthermore, when I finally found the CreatiVision's cassette port pinout, I realised that the pin next to the ground pin, which I was using for the ground reference, was indeed a power pin. Unfortunately, not the regulated 5V power we want, but power nonetheless. As it turns out, the cassette port power pin is the unregulated, approximately 9V, DC input to the onboard 5V regulator. So it seemed to make more sense to instead use a 2-core wire to pick up both the ground and the 9V supply from the console's cassette port, given that we needed the ground connection anyway. This then does away with needing a separate power supply. I've therefore replaced the USB-C power module on the CreatiVision controller with a 5V regulator and a new DC power input terminal for ground and 9V DC connection. This 5V power feed also remains isolated with a Schottky diode, so you still have the alternative of the J6 direct PIA connector 5V power supply pins. Right, let's talk about the second and more significant change. Recently, I got myself a brand new, recently released Atari CX78 Plus joystick gamepad. This is a virtually exact recreation of the original Atari 7800 dual button gamepad controller from the 1980s, re-released as an accessory for the also recently released Atari 2600 Plus console and also the upcoming Atari 7800 Plus console. With one of these controllers in my hand, it occurred to me that this would make a perfect controller for a CreatiVision console. Still only 8 directions, but importantly 2 buttoned, and also currently available to purchase brand new. Furthermore, Atari has recently announced that this summer, late November, they are releasing a wireless version, which uses a DB9 wireless dongle. This also allows these wireless Atari 2-pad joypad controllers to be used with the original Atari 2600 and the recent 2600 Plus consoles. This means we'll be able to buy brand new, wired and also wireless Atari CX7800 Plus 2-button joystick gamepads. Awesome! One of the good things about the Atari 7800 dual button controllers is that they were designed so that by default either button can replicate an original Atari joystick single button. However, if the buttons are read in a special way, you can also detect that it is an Atari 7800 compatible dual button controller, and then appropriately read the 2 button values separately. Now, to do this magic, it is necessary to interface all 7 joystick control pins. That is, the 4 direction switches the single button pin 6, as well as both the additional pins 5 and 9. Currently, with the existing version 1.2 CreatiVision Controller, I only interfaced to 6 joystick control pins on each joystick. So we need 2 more GPIO inputs on our microcontroller to allow supporting for auto-detecting and using both left and right Atari CX 7800 Plus controllers in 2-button mode. Unfortunately, the 28-pin AVR DA microcontroller that I'm currently using only supports a total of 23 GPIO, including the pin that I'm currently using for the optional hardware reset circuit. We now need 24 GPIO pins. That is 8 for the MT8816, 2 for the PS2 keyboard port, and 7 each for the 2 joysticks. So 24 in total. With the existing microcontroller, we are 1 GPIO pin short. Fortunately, I found that Microchip's recent AVR EA microcontroller family has the same pinout as the DA series, but now supports 24 GPIO. It does this by also allowing the previously dedicated UPDI programming pin to also be redefined as an additional GPIO pin. So, I can reassign both the reset and the UPDI pins to the needed extra 2 joystick GPIO pins, and still use our familiar retro-friendly 28-pin through-hole AVR 8-bit microcontroller. Great, but there is one small issue. In order to program the AVR EA family, when using the UPDI pin as a GPI pin, you need a high voltage capable UPDI programmer. The newer high voltage component is how the GPIO assigned pin can be overridden to enable its UPDI functionality. Although my existing MP Lab Snap programmer does UPDI, it unfortunately doesn't support high voltage UPDI. So, it looked like now was the time I should make the jump to the more capable PICKit 5 in-circuit debugger programmer. These are more expensive than the hobbyist Snap device I had been using, but fortunately the PICKit 5 is relatively new and also more affordable than the previous PICKit 4 model was. So it's probably a good investment for this and future projects. So with all that explained, I now had a workable plan. First off was to develop some code to test my ability to detect and interface to the Atari 7800 2-button joysticks. So I borrowed the needed 7th joystick connection for the left joystick from the right joystick port on my existing version 1.2 controller interface. With this extra GPIO connection, I could develop the software and prove that I could both detect and utilize an attached Atari 7800 CX78 Plus controller. With a bit of debugging, I finally had this working perfectly, allowing a regular Atari compatible joystick either with one button or with a second simple button connected to pin 5 or pin 9, or an actual Atari 7800 dual button joystick, all to be automatically detected and correctly read. All is working awesomely, and my experience so far with the CX78 Plus joypad is that it is truly awesome when used as a 2-button CreatiVision joystick. So, the next step was to redesign my schematic in PCB for version 2. So, here is the updated version 2 schematic. From the schematic, you can see that the circuit is actually simplified from version 1.2, as we've managed to remove all of the jumper headers. Here is the 3D PCB render. Firstly, you'll probably notice that the entire reset circuitry, including the reset control jumper headers, have been removed. Software reset of the MT8816 has proven reliable. So the MT8816 hardware reset pin is now permanently tied to ground. You'll also notice that the pin 5, pin 9 second button selection jumper headers on both joystick ports are also now gone. The The software now detects the presence of an Atari 7800 dual button joystick, and for regular original Atari compatible joysticks, a second simple button connected to either pin 5 or to pin 9 will automatically be used as a second button, so no jumpers are required. I've also now connected 5 volts to the joystick connectors. I had left this pin unconnected previously as not being needed, but it occurs to me that the wireless SEC 7800 Plus dongles will undoubtedly use the 5 volt pin for powering the wireless functionality. Next, the UPDI version 2 standard 4-pin header now connects the microcontroller UPDI high voltage required reset pin on pin 1 of the header, which was previously not connected, as this is needed for the full UPDI high voltage support. With the reset circuit removed, I've also moved the UPDI port over to the other side of the board to better use the available PCB space. You'll also note the previous USB-C power module has been replaced with a 78M05 linear regulator and appropriate bypass capacitors. The chosen 5 volt regulator in a TO252 package is good for up to 500 mA. The controller board doesn't draw much current at all. However, the unknown factor is the power needed by a connected PS2 keyboard and also any DB9 attached wireless joystick dongles. A smaller TO92 packaged 100 mA capable regulator could have been used, but given the PS2 keyboard standard allows for up to 100 mA for driving the keyboard, I decided it was safer to go with the more capable 500 mA regulator. Finally, you'll note the addition of 2 protection resistors on the joystick ports. This is to protect the port pin, which now acts as a bidirectional pin when detecting and reading an Atari 7800 2-button joystick. So with the changes explained, let's get one assembled to prove it in operation. Note the microcontroller is now an AVR EA family device in the same 28-pin dual inline package, and the firmware code is now version 2. I've uploaded both the original DA family version 1 code for the version 1.2 PCB as well as the new EA family version 2 code for the version 2 PCB to the GitHub repository. Also, for those who previously bought a version 1.2 based kit set from my Tindie Store, I have already sent you a free repeat of your order for the new version 2 controller. Given the major changes and the new support for the Atari 7800 2-button joysticks, and it being only a month since releasing version 1.2, I thought this was the right thing to do. Right, so on my desktop you can see the new version 2 PCB and the components needed to build it. Let's get it assembled. And here is the assembled version 2 CreatiVision Controller. So as I did in part 2, let's first connect it up to an original CreatiVision Console. So let's make some space. And I'll grab my console. Plug in some video. And the power lead. Now the difference this time is that instead of a ground reference connection and a separate USB power lead, I've just connected the new power terminal to the ground and 9 volt outputs of the cassette board. So let's get the controller board. I'll connect up power first. So now we have all-in-one power. The controller interface is now powered by the CreatiVision's on-off switch. So let's get the controllers connected. And the left port. Then we can hook up a PS2 keyboard. And lastly, I'll hook up my Atari CX78 Plus 2-button joypad to the left joystick port. And I think we're ready to go. Right, I've just selected Controller Diagnostic B on my Mega cart, so let's power it on. And a reset. Let's check the keys are working. 1, 2, 3, 4, 5, 6. And the joypad. So we have up, down, left, right, diagonals, and right button and left button, which is the same as the shift key, which this test appears to show it as just the shift key as opposed to the left button and being engaged at the same time, but it does work. So let's try my favourite Sonic Evader again. And apply power. And I hit reset and 6 to start a game. And I can use either button for fire. Probably have to get myself used to playing the games that use 2 buttons as well. I just keep coming back to my favourite Sonic Evader. Rightio. Let's power off. So now I'll change over to my CreatiVision recreation. Okay, so we've just got our controller board with the keyboard and joystick plugged in. Let's reattach it to the MECB system via the direct PIA connection. So in this case, power is supplied via the PIA connector, as already seen in part 2. So let's apply power. And at the moment I'm switched to basic. So again we can see the keyboard going. Let's see if we can find the same diagnostic. Reset again. And we have keyboard. And again let's try the joystick. All good. All good. So once again we have the dual button Atari CX78 Plus automatically detected and in full 2-button operation. So sorry for such a short demo, but this was really about the update to version 2. So I'm really happy with my version 2 CreatiVision controller, which I believe now finally delivers the ultimate CreatiVision controller interface. Teaming it up with the new Atari CX78 Plus joypads is awesome, and I already have my pre-order in for the wireless Atari CX78 Plus when they get released in late November. Hopefully Some of you get to have as much fun using my version 2 CreatiVision Controller interface as I've had designing it. I thought I'd just add this segment to the end because I finally realised when I turn on the diagnostic B and get a blank screen, instead of pressing reset, it's actually displaying the keys I press. 1, 2, 3, 4, 5, 6. So it's actually a good way of testing because now we can clearly see all the angles on the joystick, and also button 1 is the left button and the shift key, and button 2 is the right button and the control key. And I can press other keys as well. Etc. Just thought you'd like to see that. Actually, I'll also show you the right joystick working, because I haven't shown that before, although I have tested it obviously. So for the right I can do all the directions, and equals is the left button as well as the button, and the right button is the right arrow plus the right button. Rightio. That's it. Thanks for watching.